The Japan 2011 Tohoku earthquake. When and where? On March 11th, 2011, at 5:46 in the evening local time, an earthquake struck under the sea about 45 miles east of the Tōhoku region of Japan. The depth was only about 20 miles beneath the seafloor with a magnitude of 9.1. It was the strongest earthquake ever recorded in Japan. The shaking lasted about 6 minutes and it's remembered as the Great East Japan Earthquake. At first, the magnitude was reported at 7.9, but it was upgraded multiple times until the final value of 9.1. Four shocks had already been occurring in the days before, including one at a magnitude 7.2 and several others above a magnitude of 6. This event took place in the Japan Trench, where the Pacific Plate is being subducted beneath the Okhotsk microplate, part of the large North American plate. Subduction zones are known for producing the world's largest earthquakes. The Pacific Plate moves about 3 to 3.5 inches per year, creating strain beneath Honshu. On this day, a massive rupture occurred, slipping as much as 50 meters in some places. The release of energy from the fault caused the seafloor to shift suddenly, which displaced the water above and set off a tsunami. The tsunami waves reached about 133 feet in height, traveling at 435 miles per hour, and moved as far as 6 miles inland. The tsunami inundated 2,000 kilometers of coastline from Hokkaido down to Kyushu. The waves also crossed the Pacific with heights of more than 6 feet, reaching Chile. Residents in Japan only had about 10 minutes of warning before the first wave struck.
In the aftermath, aftershocks continued for more than 1 year. There were about 1,000 in total, with around 80 of them measuring between magnitude 6.0 and 7.7. The strongest shaking, Japan's seismic intensity scale, was recorded in Miyagi Prefecture, with very strong shaking, also measured in Fukushima and Ibaraki. Northeastern Japan shifted nearly 8 feet closer to North America. Near the epicenter, the seabed moved about 24 meters, with some areas closer to the Japan Trench shifting as much as 50 meters. Parts of the seafloor were uplifted as much as 7 meters. Cracks were also observed in the roof of Mount Fuji's magma chamber after the quake.
The human impact of the event. 6 months after the earthquake, there were over 15,000 recorded casualties from the initial earthquake, tsunami, and aftershocks. The majority of these casualties were elderly and first responders. Roughly 370,000 homes were damaged or destroyed from the earthquake and its effects, resulting in over 340,000 people being displaced from their homes. An estimated 300 billion USD worth of damages occurred from the earthquake and its aftermath. Japan is a manufacturing powerhouse for many things around the world. Global supply chains were broken and the stock market took a big hit. The earthquake triggered the second worst nuclear accident at the Fukushima Daiichi plant. The plant's reactors were successfully shut down, but the residual heat caused fuel rods to overheat and lead to the release of radiation. To the left is an image depicting the Japanese market fallout, and to the right is the aftermath of the Fukushima Daiichi plant after its reactors overheated.
The environmental impact of the Tōhoku earthquake and tsunami. The landscape was greatly affected by this event, specifically the groundwater being infiltrated by salt water and pollution that came in from the ocean when the tsunami hit. This didn't only hurt humans but affected the ecosystem as well. Coastal areas were removed of silt, majorly tarnishing coastal ecosystems. The earthquake portion caused landslides near coastal areas, further hurting these crucial ecosystems. Building destruction had a major impact on the amount of gases released into the atmosphere, about 6,600 metric tons, due to insulation and other equipment appliances. Halocarbon levels, gases that deplete the ozone layer, increased from 21 to 91% above typical levels following the earthquake. These effects weren't only local, regional, but they were global. This devastating event affected the biosphere, atmosphere, hydrosphere, and lithosphere.
According to Lucy Jones, chief scientist for Multi-Hazards Project, the 2001 Tōhoku earthquake was the best recorded earthquake ever. Thanks to this, there has been an outpour of new quake sensor data. It has now given scientists the possibility to model what happens during a rupture of an earthquake, including data on how it accelerates and decelerates. Gravity signals have not been detected until now. and now they can allow an early warning of earthquakes before seismic wave arrival. Data was collected by a superconducting gravimeter and broadband seismometers during this earthquake. This earthquake could lead to developments in gravity gradiometers that could open new directions in earthquake seismology. These are our sources for today and for our credits. Thank you for watching.